All right, this video is a video of examples of the properties of multiplication and division topic from Study Island. Here we go. Number one, which of the following is equivalent to negative 7/4? Remember, 7/4, the fraction, is just 7 divided by 4. So which of the following is equal to negative 7/4? Negative 7/4. Well, let's look here. This is negative 7 divided by negative 4. A negative divided by a negative is always positive. So those two negatives are going to cancel each other out. And your answer for A is just going to be 7/4. That's what that would be equal to. So that is not the answer. This one, B, we have positive 4 divided by negative 7. Well, positive divided by a negative is a negative, and then 4 divided by 7 is just 4/7. That's not what we want, because we want 7/4. We want the fraction flipped over there, the reciprocal of that. So neither of those two are the answer. C, that's just 7 divided by 4. There's no negative there. It's just 7/4. That's as simple as you can make it. That would just be 7/4. So that's not the answer either. And then finally we get to D, which has to be the right answer because it's the only one left. We have a positive divided by a negative, which is negative, and 7 divided by 4 is 7/4. So that's our answer, negative 7/4. The fact that there's parentheses around the 7/4 does not affect its value. Number 2. Tanya has a small picture with a length of 4 1/5 inches. She wants to enlarge the picture by a factor of 7 and frame it. Which of the following is true? So the length is 4 1/5. She wants to enlarge it by a factor of 7. The enlarged picture has a length of 16 inches. The enlarged picture has a length of this, a length of that. Let's figure out what the length is. We simply have 4 1/5 times 7. Now, there's two ways to do this. I can do 4 1/5 as an improper fraction, and a lot of you guys get taught in elementary school to do it this way. So I'll do it this way first, but then I'm going to show you a better way to do it. 4 1/5 times 7 can be 4 1/5 times 7/1. And 4 1/5 could be 5 times 4, which is 20, plus 1 is 21. So 4 1/5 is 21/5. 21/5 times 7 is 21/5 times 7/1. And now we just multiply across because nothing simplifies. 21 times 7 is 147, and 5 times 1 is 5. At that point, 147 divides by 5. How many times? Well, I know 5 goes into 150 30 times, so this is going to be 29 times 5 to get to 145. The 2 left over, so it's 29 2/5. If you want to see the long division for that, it looks like this. 147 divided by 5. 5 goes into 14 twice. 2 times 5 is 10. Subtract 14 from 10, 10 from 14, you get 4. Bring down the 7, you get 47. 5 goes into 47 9 times. 9 times 5 is 45. You subtract, we get 2 as a remainder, so 29 2/5. So 29 2/5 inches is our answer. So we know it's C. An easier way to do this problem, I think, is to remember that if you have 4 1/5 times 7, that is equal to 4 times 7 plus 1/5 times 7. You don't have to multiply 4 1/5 times 7 all at once. You could do the 4 times 7 and the 1/5 times 7 and just add them together. 4 times 7 is 28. 1/5 times 7 is 7/5. And then 28 plus 7/5 is 1 2/5 because 7 divides by 5 once with 2 left over. So 28 plus 1 is 29, and you get your 29 2/5. To me, that's an easier way to do the problem, but either one will work. Next, integers can be divided, provided that the dividend, divisor, or quotient, you got to know what those are, is not 0. Given this, every quotient of integers is a negative, positive, rational, or whole number, and if p and q are integers, then the negative p divided by q is one of these. So we've got a lot of stuff here that we have to make sure that we understand. It's a lot of terminology. First things first. Integers can be divided, provided that, and we have three different terms here to choose from. A divisor, a dividend, and a quotient. What these three things mean is pretty simple. Dividend is the number you're dividing. The divisor is what you're dividing it by. and a quotient is the answer. So let's take a really quick, easy division problem so that we can identify that really quick. Let's say we had 12 divided by 6 equals 2. 12 divided by 6 is 2. 12 is our dividend. It's the thing being divided. 6 is our divisor. It's what we're dividing it by. And 2 is the quotient. So let's get back to our problem. Integers can be divided provided that the what is not 0. What is not allowed to be 0? The thing you divide by, the divisor. The divisor can never be 0. You cannot divide by 0. So there's our answer. Given this, every quotient of integers is a what? Negative, positive, rational, or whole number. Well, integers can be positive or negative. So if you have two positives, then the answer is positive. But if you have a positive and a negative, the answer is negative. If you have two negatives, the answer is positive. So it's never either one of these. It could be both, or excuse me, it could be one or the other. It can't be both at the same time. So you can have a negative answer or a positive answer. You can't have both at the same time. So we can't say it's always negative or always positive. What's a whole number? A whole number is an answer that is a number that does not have a fractional part. So it would have to be 2, 3, 4, 5. But if I take two integers or two whole numbers that don't divide evenly into each other, like say 5 and 3, 5 divided by 3 is going to have fractional parts because 3 doesn't go into 5 evenly. So that leaves us with a rational number. The definition of a rational number is one integer divided by another, or a number that can be written as one integer divided by another. So lastly, if p and q are integers, then negative p over q is equal to which of these? Well, negative p divided by negative q is what that says, equals negative q divided, no, you can't just flip them around. That's not, reciprocals aren't necessarily equal to each other, so no. Or is it negative p over q is equal to negative p divided by negative q, which equals positive q divided by negative p? No, again, you can't flip the fractions over. You have to keep the number in the numerator, and the number in the denominator. You can play with the negative signs. Let's keep going. Negative p over q equals p over negative q. That's our answer. I'll write it a little bit more clearly so that we can see that. It's negative p over q is equal to negative p over q, which is equal to positive p over negative q. That's what's true. Negative fraction is equal to the negative divided by positive or positive divided by negative. But either way, it's p over q. It doesn't matter if the negative symbol is out in front, saying the whole thing is negative, or if the negative sign is in the numerator, saying the numerator is negative, dividing by a positive denominator, or if the negative is in the denominator, saying we have a positive numerator dividing by a negative denominator. These three things are all equal, and it's that answer that says so. Number 4, which expression represents another method of computing a given product below? So our product, the thing we're multiplying, is negative 2 3/7 times 0.01. So it's another way to write that. Well, I have a whole bunch of options here. So let's see. This is negative 2 3/7 plus 0.0. Multiplication and addition are completely different things, right? So it's not A. B, negative 1 times negative 2 3/7 times 0.01. Well, the back half of this, where it says negative 2 3/7 times 0.01, is exactly the same. Why would multiplying by negative 1 keep it the same? It's going to make it its opposite. So it's not B. Next one, negative 1 times 2 3/7 plus 0.01. Again, we're adding the 2 3/7 on the 0.01. That's not it. Or lastly, this one, negative 2 times 0.01 plus negative 3/7 times 0.01. That is a little bit like what we had earlier. I showed you in a previous problem that you can multiply a mixed number times another number by just changing that mixed number into an improper fraction and multiplying straight across, or you can divide them up. Like 4 1/5, I divided into 4 1/5. Well, in this problem, what they're doing is they're taking negative 2 3/7 times 0.01, and they're breaking the negative 2 3/7 into negative 2 and negative 3/7. because -2 plus -3/7 is -2 3/7. We can multiply these individually by 0.01 and add them together. So that's what that says down there. 5, drag each expression to the correct location on the table. Not all expressions will be used. So consider the equation below. Identify the correct steps used to evaluate the expression and place the expressions in the correct order in the table. So our original expression, 23/4 times the sum of 7 6/7 times a half times 4/23. All right, so if we were going to do all that, what would we do first? Well, we got lots of options here. According to what we have here, I would add the parentheses together first. 7 plus 6/7. What is 7 plus 6/7? Okay. If I have 23/4 plus 1/2 times 7, I'm going to write 7 as 7/1 plus 6/7 plus, times 4/23. Here we go. 7/1 plus 6/7. I can't add those together without common denominators. So I have to multiply 1 times 7 and 7 times 7 in order to match the denominator up at 7. So 7 times 7 and 1 times 7 makes this whole new problem 23/4 plus 1/2 times 7 times 7 is 49. 1 times 7 is 7 plus 6/7 times 4/23. Now I can finally add them together. So I have 23/4 plus 1/2 times what? 49 plus 6 is 55, so this becomes 55/7. And then times 4/23. So which step is that? What do we have right here? That is this one. 23/4 times 1/2 of 55/7 times 4/23. Step 2. Step 2 is to reorganize this because it's 3 things we're multiplying together. We're multiplying together 23/4. I keep saying plus. I have no idea why I said plus all those times. It was times. So I apologize for that. We're just multiplying 3 things together. When you multiply, order does not matter. So I'm going to put my 23/4 and my 4/23 next to each other. My ability to reorganize those in any order I want is because of the commutative property of multiplication. I can rewrite this as 23/4 times 4/23 times 1/2 times 55/7. So that's my new problem. And again, all of this, it's actually 4 things I'm multiplying together. I'm just keeping these parentheses and these dots consistent, but I could put a dot between the 55/7 and the 1/2 just as easily. But because it was written that way, I'm trying to be consistent. It's 4 things we're multiplying together. We're multiplying 23/4, 1/2, 55/7, and 4/23. All I did was reorganize this and this so they were next to each other. Why did I do that? Because what you can do is cross these out. They simplify. 23 and 23. They're going to divide. That makes 1. 4 and 4. They're going to make 1. Anytime you multiply a fraction by its reciprocal, the answer is 1. The reciprocal of a fraction is that fraction flipped over. So 23/4 and 4/23 are reciprocals of one another. If you multiply a fraction by its reciprocal, the answer is 1. So we would get 1 times 1/2 times 55/7. So what are the steps that say that? We can find this one here, 23/4 times 4/23 times 1/2. That's the one I wrote right over here. Next, 23/4 times 4/23 is just 1, so I have 1 times 1/2. I don't really need the 1 times part anymore. It's just 1/2 times 55/7. 1 times anything is itself, so writing the 1 times that is redundant. And now I can simply multiply these together. 1 times 55 is 55, and 2 times 7 is 14. So we get our answer 55/14. This is enough of an example set for you. Let me know if you have any other questions. Keep working on.